Hi, this is Tom, and this is lesson 21, the z-score. So today we're going to look at a problem where we ended in our last set of homework. And the problem was this, is that if we have a normal distribution, and of course we have a mean in the zero, we'll just use 1. Say we have a standard normal distribution. So this would be the normal distribution with a mean of 0 and a standard deviation of 1. So then I could go 1, 2, and 3 standard deviations above the mean. And I could go the other way as well. 1, 2, 3 standard deviations below, and those are -1, -2, and -3. So here's the question. So far, what we've been able to do using the empirical rule is if I asked you to find the percentage of the area between 1 and 2, we could use the empirical rule, to figure out what that would be. However, what if we change the question just a little bit? So let's change the question, and we'll change our question in red because it's very important. What if we change the question to this? What if we wanted the area to the left of 1.5? In other words, we wanted all of this region here. Well, the problem becomes that our empirical rule tells us nothing. It tells us nothing at all about when we don't land right on a standard deviation. So that's what we're going to do today. We're going to find out how we deal with values that are not exactly on standard deviations. So if you recall, we called the values here on our horizontal axis, these are called z-scores. And what we do is this. We want to find the red area. So let's do this. Find the red area. And here's how we do that. What we do is we use a table of z-scores, and I have one right above. So remember 1.5, and we're going to look that up. So as we go up, notice this nice picture right above. And what this picture is telling us is that this gray region here, that gray region there, is the number that's being provided for us in the tables. So let's come back up. So here's how we use our table of z-scores. We'll do this with a highlighter. So notice this. I have in this left column, whoa, that's really big. Let's go a little smaller. So in my left-hand column here, I have numbers in whole numbers. So for example, these are in whole numbers, whole and tenths. And then over here on this horizontal row, I have numbers, these are in hundredths. So for example, suppose, let's try this. Suppose z is 0.64. How would I look that up? And then we'll do the other one. So what I would do is I come down this vertical column till I come to 0.6. And then over here in the row, I see where I have 0.4. So then I go from the 0.6 over to the 0.04, and where they meet, where they cross, is the area. So that would be 738.7389. So let's do this with the problem at hand. The problem at hand says 1.50. So here's 1.5. There's my 1.5 row, goes all the way to the right. And then 0.00, that's this first column. So right here is my answer, 0.9332. So let's go back down here. And the area in the red, we say that this is the percentage of our picture with a z-scores are below 1.50 is equal to 0.9332. 2. Or if you wanted to write it as a percentage, you could write this as 93.32%. And that's how we use our tables. So we're going to try a few more problems here. Let's do this. Let's draw it again in blue. So this is my standard normal curve here. And try to make a better one than last time. Well, that's a little better. It's kind of shaky, kind of disappointed. So let me see if I can do better here. So there we go. That looks better. So again, just for the sake of clarity, my mean falls right in the middle at 0. Standard deviations of 1, 2, and 3. So those are positive on the right. And then to the left, we have -1, -2, and -3. So let's try a value of this. And we're going to use this notation that we used above. So I want to find the percentage of z-scores. Let's go below. Oh, and I made a mistake up above. This should be less than 1.5. Less than 1.5. So we're going to do another one. Probability that z is less than. Let's try, how about negative? Go back to my blue here. -1.37. So if I draw my picture, -1.37 is about there. So let's shade that in red. And so we'll do that. So that's the area of the picture that I want to find. So to do that, we're going to have to go back up to our table of values. And this time, look at this first page only has positive z values. But if I keep going, I'm sorry, the second page actually, the first page is up here. So now we work the same way. We come down here on the left, we find -1.3. Oh, and I just passed it. It's right there. So somewhere in here, I need to find the -1.37. So we come up to this top row, and right there is my 7. So 0.07, I come down this column. And where these two meet, right there at 0.853, that's my answer. And so then I can come all the way back down here, and I could say 0.08, oops, I forgot already, 53. 0.0853, or if you wanted as a percentage, this would become 8.53%. Okay? Now, let's make this problem a little bit more interesting here. There's two ways we can do this. So let's try this. I'm going to make us another curve. And what we're going to do is we're going to find the percentage of data in, we'll do this, not in, but let's do between, oops, I wrote that one wrong, didn't I? Between, let's use, how about -0.83 and 0.55. Let's try that. Now remember, I'm going to put a colon there because really in math notation, this would be written as -0.83 less than z be less than 0.55 parentheses. That would be the math way of writing that nice long sentence. So here we go. I'm going to start with a picture. I think pictures help explain things. So let's draw this picture here. There. And let's make our normal distribution. And let's put our center here at 0. And again, we'll label it 1, 2, and 3. And 1, 2, and 3 the other way. Those are negatives to the below the mean. And I want to look negative 0.83. Well, that's probably about there. That would be, I'll bring this down. This is my negative 0.83. And then we want to go all the way up to 0.55, which is just past the middle of 0 and 1. And so what I want is I want this region in here. Now we're going to use a few colors here, and you'll see why. So first off, let's look up negative 0.083. So when I look up, so let's all make a note of this. So we'll do this. For z equal negative 0.83, the area is, and then we're going to fill that in. And then we're going to do it for, then we're also going to do it here for 0.55. So then we'd say for z equal 0.55, the area is, put an underline, and let's go fill out, complete both of those. Now, we're going to be going up and down here, so bear with all the scrolling, but here we go. All the way to the top for negative 0.083, and let's use a different color. We'll use our light green. So negative 0.8, that's here, and notice that my 3's are right here. So our first value is 0.2033. Now, look closely, because notice that this picture down here at the bottom is telling me that's everything to the left. Everything to the left. So keep that in mind, and let's go label our picture, 0.2033. Okay, so I'm going to use a different color. We're going to use orange for this. Is 0.2033. So what that tells me is that's this orange. That's all the area to the left. And so that is 0.2033. That's the orange area. So now let's look up the next one, 0.55. So here we go. 0.55. That's going to be, here's 0.5. That's my row, and then 0.05. So we have 7088. And we're going to go down with another color, so 7088. 0.7088. Now, what that means, according to the picture, is that's everything. It's the orange, it's the red, and we're representing it with this pink color. So all of my pink is 0.7088. Now, I don't want the orange area. I don't want the pink area. What I want is the red. Well, the red area is found by taking the pink and subtracting the orange. So what we want is, I'm going to write this out, we'll use blue again, is the orange area is found as the pink area, or we'll write pink area, minus the orange. Oh, yeah. Oh, I made a mistake. The red, this should be the red area is found as the pink area minus the red area. Oh, goodness. Minus the orange area. All right, here we go. So we're going to take, and we'll do this. This is going to be the 0.7088. We're going to subtract from that the orange, and the orange is the 0.2033, and the result will be the red area, and that's what we want. So the red is going to be 0.5055. And so we could formally write our answer as the probability of z being between 0.55 below that and above negative 0.83 is 0.5055. And remember that that's also the same as saying 50.55% of the area under the normal curve. All right, I hope that helps. Thanks for watching.